Okay, so to start today's lesson, I'm going to read you guys a story. Here we go. It says, once upon a time, there were two people in love, Freddie and Frania. Freddie and Frania lived quite a distance from each other, but they wanted to meet together at least once a week. They decided they would share the cost of gas. After they sat down and did some math, they found out that they could only afford enough gas to travel 100 miles a week. Sounds simple enough, right? They should just meet halfway. But here's the thing. They hated meeting in the same place all the time, so they had to change it up every time. So, where are all the possible meeting places for them? Keep in mind the distance of their meeting place from Freddie's house plus the distance of their meeting place from Frania's house has to make 100 miles. So I put an example of one up here for you. Maybe they can meet right there. That's 50 miles plus 50 miles, which would be 100, right? But that's definitely not the only place. They're going to get sick of meeting there, so they're going to need another place. They could go here. And 20 plus 80 is 100, right? It doesn't matter if it's closer to one person's house or not. The point is the sum of the distance has to make $100 because they're sharing the cost of gas and the total distance is 100 miles. So the question is, where are all those places? So if we were to go through and find them all, eventually what you'd find is that you get an oval, okay? Or as we call it, an ellipse. Okay, so all those points on that shape are the same distance if you take the distance from Freddie's house and from Frania's house and add them together. Okay, so that's what we're talking about today is ellipses. So we're not going to do this. We'll do that later, the putting parabolas in vertex form. But we are going to talk about ellipses and graphing them. So these are ellipses. It could be vertical, like the one on the left, or it could be horizontal, like the one on the right. Alright, the two extreme ones that kind of represent Freddie and Frania's house in the example I gave you, those are the foci. Once again, I picked names that start with the letter F to kind of help us illustrate that. And of course, the middle we'll call the center. Now, you guys know on a circle, the radius, the distance from the center to the sides is the same all the way around, right? It's not true, obviously, with an ellipse. You have a longer axis and a shorter axis. The longer axis is the one we call the major axis, and the shorter one is what we call the minor axis. You guys can go ahead and call the distance from the center to each focus as C. Okay? We'll talk about the A and the B in a second here. So what axis are you guys noticing the focus is on in both ovals or both ellipses? It's on the major axis. That's where the foci are located. Okay. Now down here is an equation. It's not really the major axis. I should put here it's the major axis, or half of it really, and half the minor axis. In other words, it's the A and the B distances. Like A is half of the major axis and B is half of the minor axis. So your formula is basically those half distances squared. If you subtract those, it should equal the C squared. And we're going to use that later to actually find out what the focus is. So after we've got everything established here about what makes an ellipse, the radius that goes from the center to the longest side is what we call the focal radii, but I think we're going to hold off on that vocabulary for right now. It's not something we're going to be using a whole lot today. But here's what I'd like you guys to take note of. Write down the equation of the ellipse, but you don't have to write down both of them. Just write down one. Well, this is the equation for an ellipse. It looks a lot like the equation for a circle because it's a lot like a circle, but it has a difference from the circle. The circle was equal to r squared. We're going to have this one equal to 1. And also, these things have denominators. Those denominators, what they do is they tell you what the radiuses are for each letter, so to speak. So like, for example, b squared is under the x, right? That tells you that the x radius, if you want to call it that, equals b. And this one tells you that the y radius is a. And you guys can... Alright, so let's go ahead and do some examples here. We're going to start off by graphing. So go ahead and write down example 1 and the directions here. So before we do it, h and k are going to represent the center just like they always have, okay, for these circles and conics and whatnot. So h and k is our center, and b is like our x radius, and a is like our y radius in this case. So let's go ahead and do this one. What is my h and k? What is my center? It's the h is 3, and there's no k, which means that that would be 0. Okay, so my center of my ellipse is 3, 0. Now we have two different radiuses here. We have an x radius and a y radius. It's really not technically correct to call them radiuses, but we're going to kind of treat it like that. So that's my own words. I want you guys to understand. But the x radius is going to be found by looking at the number under the x part. So that's this guy. So that's our b squared. So what is b? It's 2. You take the square root of it, right? So the square root of that is 2. So my x radius is 2. And what about the one under the y? You square root it, that'll tell you the y radius, which is 3. Okay? Now that we know that information, we can graph it. Okay, so we're going to find our center first, 3, 0. That's over 3 and up none. So we'll put a dot there. Now my x radius, that's the number that tells me how far to go left and right. So I'm going to go left and right 2 and put a dot. So left 2, right 2. And my y radius is 3, so I'm going to go up 3 and down 3. It might not look like an ellipse because of the way I drew my graph, but the point is that the y direction should be longer than the x direction slightly. Okay, so we have 5x squared plus 3 parentheses y plus 2 squared equals 45. This is not in the appropriate format. Okay, let's take a look back here. It's got to be equal to 1, first of all. The problem we just looked at is equal to 45. And you can't have any coefficients or numbers in front of the parentheses here. All we want is denominators. But we're going to go ahead and clean it up, and here's how you do it. How can we make 45 equal 1? There you go. You just divide it by itself, right? So whatever you do to one side, you're going to do to the other. Christian? So we divide everything by 45. And now by doing that, the right side becomes 1. And on this left side, what we can do is those numbers in the front that we don't want, we can reduce them with that 45. So how many times is 5 going to 45? 9 times. So if you reduce the top and bottom by 5, right, you would get x squared over 9. We'll do the same thing with this other one. What goes into 3 and 45? 3, right? So if you just divide that top number to the top and bottom, you'll get your answer. So 45 divided by 3 is 15. Now it's in the appropriate format. So what's the center now, guys? 0, -2. Good. And my x radius? What's my x radius? It would be 3, the square root of 9. And the y radius, well, it's going to be an imperfect number, right? The square root of 15. So let's get an approximation of that. And I'm getting 3.9, which is pretty much 4. So when we graph it, we'll just kind of use 4. The center was 0, -2. My x radius was 3, so I'm going to go left and right 3. And we're estimating the y radius to be about 4. And there it is.